Good evening, everyone. Very good evening. Am I audible to you all? Am I audible, everyone? Okay, guys, we'll start by 7:15. Okay, just 3 minutes more. Your friends are join. Okay, let them join. Just 3 minutes more. Revise the concept. Okay, guys, we shall resume back. Okay. Yes. Yes. Yesterday's concept only. Okay. So yesterday we were doing right, and suddenly there was some technical issues. Okay. We shall complete that today. Okay. We shall complete that program. Okay, and then we'll go further with the next concept. Okay, we were doing one program. It was a book program, right? So let us get into that. Let us go for your this one Eclipse. Let us go for Eclipse. Okay. Um, Let it open. Okay, and yeah, let us go for your this one. Okay, in interface programs, I think we had a class book. Okay, so what did we do in last class is we have created a class book and we have implemented a comparable interface. We have implemented comparable interface. So what does comparable interface do? It will allow one method called as compare to method. It will allow a method called as, it will give us a method called as a compare to method. Using this method, we will be able to compare an element. Okay, one attribute will be able to compare. So either price or ID or the title of the book, anyone will be able to compare. So currently we are comparing the price of the book. So what we have done is we have created an array of size 5. We have created an array of size 5. Okay, and now we are trying to compare only the prices. We are trying to compare only the prices. Okay, so what we have done is we have written one logic here. The logic is, if the current price and the past price, okay, I mean the current price and the past price, okay, is same. If it is same, then return 0. If the current object price and the past object price is greater than, I mean current object price is greater than past object price, we shall return 1. If current object price is lesser than the past object price, we shall return minus. Okay. So this is the logic. So why this logic we have to go for? What is there in this logic? Okay, let me tell you. Let us go for the paint first. Okay. So the logic here is, okay, logic here is very simple. Okay. See guys, always remember 0, minus 1, plus 1. Okay, in this line. Now, So what are the prices we have there? Prices, object prices. Let us see. Okay, let us go to Eclipse and see the prices. Once again. Okay, the prices are, let me write down all of them. 456, 120, 75, 60 and 250. Okay, now these are the 5 prices of the objects. Okay, next what we shall do here is very simple. Okay, very simple. First we have to take the first element. Okay, that 456. You have to take 456 and compare with 120. Take 456 and compare with 120. Okay, so okay, so now 456 is greater than 120. 456, and we also have to see the thing is, if it is equal to we have to return 0. If it is greater than, we'll return 1. If it is less than, we'll return -1. Okay, so this is the logic we have written. So here 456 is greater than 120. 456 is greater than 120. So since it is greater than 120, we will write the value towards the positive lane. Okay, we'll write the values towards positive lane. So we'll write 456. Okay, next. So first one 456 done. Next we shall go for 120. Okay, we shall go for 120. We will take 120. Okay, we will take 120 and check with all. Okay, that means we have to check with 456 and 120. So 456 we have taken, compared with 120. Okay, next we shall take 120 and 75. We shall take 120 and 75. Okay, so 120 is greater than 75. Yes, so we have to write 120 here in the positive line. We have to write. Okay, so here we'll be writing 120. The thing is here if you compare two. Okay, here if you compare two objects. Okay, 456 is greater than 120. 456 is greater than 120. So 120 will come before 456. Okay, 120 will come before 456. Okay, and next. Okay, so 75 will compare with all. 75 we will take, will compare with 456, 120 and 75. We will take 75, compare with 456, 120 and 75. Okay, 75 we will take. Is 75 greater than 120? Greater than 120? No, 75 is less than 120. Less than means -1. So towards this negative side. Okay, so you'll have 75 towards the negative side. Next, take 60. Okay, take 60. Compare 60 with all values. 60 with all values. 60 with 456. Obviously 456 is greater. So positive value will write. And since we have more values, we have to compare with all. So 120, 60 with 120. Obviously 120 is greater. 60 with 75. 60 is the lowest compared to 75. So 60 is less than 75. 60 is less than 120 and 60 is less than 456. So it is less than. So towards -1, it will become 60. Okay, next. After this, so we'll take 250. We'll take 250 compared with 450. 250 is less than 456. Yes, condition is true. Usually 250 will be around here. But again, you have to compare with all other. Next, 250 is less than 120. 250 is less than 120. No. 250 is less than 75. No. 250 is less than 250. Okay, no. So here 250 will come around here. So 120 here and 250 here. Okay. Now here we got the elements as first 60, then 75, then 120, then 250 and 456. Okay, just you have to see which is greater than and which is less than. Here I have written, but according to this logic only, according to this logic only, the elements will get sorted by the sort method. Elements will get sorted by the sort method. So just remember, these values are already sorted now. How? We have called arrays dot sort method. We have called arrays dot sort method. This sort method I've already sorted. Okay, this sort method, has already sorted the array elements. That to whom it has sorted, it has sorted only the price. Why only price? Because we have compared only price. That is why. If you take any other thing, see, suppose if you take id, book id, okay, we have figured book id, so you'll not get it traced. I mean, in an ascending order it will not be sorted. Okay, let us show the output. Now can you see, the output is obviously different. Okay, it is different, it is not in ascending order. No, it is not in ascending order. But in case if you take, okay, if you take price, all the prices will be sorted. All the prices, all the 5 object prices will be sorted. Can you see here? 60, 75, 120, 250 and 456. Okay, so this is all the elements, I mean all the attributes which we have sorted. Okay, the attributes only which we have sorted. Currently we have sorted price. So since we have sorted price here, okay, so out of this, I mean in this objects, we have taken all the prices and we have sorted it. Okay, and we have called arrays dot sort method. So the sort method will sort the elements based on the logic here written. Okay, now here we have taken a for loop to print all the elements. We have taken a for loop to print all the elements to make sure it has already been sorted. To make sure it has already been sorted. Okay. So this is about your comparable interface. Comparable interface provides one comparative method to sort a array object. To sort array object. So here if you see the logic, based on this logic only, this sort method will sort the array elements. Okay, and by default we can only have one natural ordering. That's it. That means we can sort the elements by default in ascending order. We can sort the elements by default in an ascending order only, by default. Okay, so this is how your comparable interface is. Okay, now we have some disadvantages here. Okay, we have some disadvantages. Now let us see what are those disadvantages. In this also we have disadvantages. See, without any usage of any built-in sort methods, we have actually sorted the array objects. But here some disadvantages is there. See guys, if the objects are not of comparable type, if the object is not of comparable type, obviously we can't use built-in sort methods. Okay, and here we can sort all the elements, whatever the attributes we have, all the data we can sort accordingly in one order. If you want in descending order, we can't do it here. We can't do it. By default it is like this only. Okay, descending order, if you want, we have to change the logic here. But by default it will not be in a descending order. We have to change it. Okay, so what is the disadvantage of comparable interface is we can sort the object only in one defined order, that is a natural order. Okay, if the objects are not of comparable type, then we can't sort using built-in sort methods that I already told you. Okay, and we can overcome these two disadvantage. We can overcome these two disadvantage with the help of comparator interface. With the help of comparator interface. So comparator interface is an interface, okay, which is present in excuse me, which is present in java.util package, which is present in java.util package. Okay, and this comparator interface is also called as a functional interface. It is also called as functional interface. So guys, can you tell me why do we call an interface as a functional interface? Anyone? I have taught you in this. Yeah, that is what I'm telling now. Here, that is the disadvantage here. We can only sort any one element. Yes, that is also disadvantage here. We can sort any one element. All the elements we can't sort. Any one element we can sort. Now, to overcome this, that is, we what all the attributes are there, we have to sort all. The first thing is we have to sort all the elements. Next, we have to we have to have a logic for the reverse also. Reversing also we need to get. Okay, and for all the data in an array objects, we have to sort neatly, and here we will achieve sorting for all the attributes. And here what changes we'll get is we have to create an instance for that array. Okay, you will see how to do that. Okay, so guys, why we tell a method, I mean interface as a functional interface? Yes, because it has only one abstract method. Okay, it has only one abstract method. So we call comparator interface as a functional interface because it will have only one abstract method. One abstract method. Okay, next, here, now let us see the method declaration of comparator interface. Method declaration of comparator interface. See, we have a method inside a comparator interface. We have a method in comparator interface. The method name is compare method. The full name is public abstract int compare of object O1 comma object O2. Okay, semicolon. So this is your compare method. Okay, this is the compare method from comparator interface. Okay, this is the method, compare method from the comparator interface, So compare method is from comparator interface, and comparator interface is a functional interface, which means it has only one abstract method. Okay, now how to use this? How to sort all the attributes? All attributes we have to sort here. It's not like only price, only book ID, only this. No, we have to sort everything. Suppose there is an employee. Okay, there is an employee object. Employee name is there. Employee ID is there. Employee salary is there. We should be able to sort all of them in ascending order also, and we have to sort them in descending order also. We have to sort them in ascending order also. We have to sort them in descending order also. So this is the thing. Here in this comparable interface, we can sort in only one order. That to anyone we can take, and we can write the logic, and we can sort in one order. But here in the comparator interface, we can sort all the objects, not only employee name, ID, or salary. Everything we can sort. Okay, everything we can sort. So how to use this? How to sort every object? See, if you take an employee object, to sort an employee name, we have to create one class, and we have to implement comparator interface. If you want to sort employee ID, you have to create one class for that, and you have to implement comparator interface. Excuse me. If you want to compare the salary, you can go for a class. You have to create a class which implements comparator. Okay, comparator interface. Okay, so here, if you want to sort all the attributes, you have to create a separate class, implement comparator interface, and override compare method. Okay, so let us see how we can do it. Okay, so let us create one employee class. Class employee. Now, so currently we have a class employee here. Now we shall go for name, string employee name, and int employee ID and double salary. Okay. Next, we shall also go for a constructor. Source, generate constructors using fields. Generate. Okay. Next, what we shall do is nothing. That's all. Nothing. Okay. So here we have a class employee. Okay. And we have a constructor for it. We have a constructor for it. Okay. Next, what we have to do is if you want to compare employee name, if you want to compare employee name, you have to create one class. If you want to compare employee ID, you have to create one class. If you want to compare salary, okay, you have to create one class. So let us create those classes here now. Okay, in the same file we shall create class. Okay, sort by ename. Sort by ename. Step 1, if you want to compare an attribute, you have to just create one class. Any name you can give. I'm giving sort by ename. Step 2, you have to implement comparator interface. Comparator interface. It is from java.util package and we have to import it. See, we have imported excuse me, we have imported comparator interface. We have imported comparator interface. Next. So next we shall go for here. Okay. So we are implementing comparator interface. Since it is from util package, obviously we have to import it. Only lang package members will be imported by default. Okay. Now sort by ename is there. Next, what we have to do is we have to override the compare method which is present in sort by ename. We have to override compare method which is present in comparator interface. Okay. Next. So what we have to do now is listen carefully. There we had one object. There we had one object. There we had one object, but here we have two objects. There we had one, but now here we have two objects. So since we have two objects, we have to downcast it twice. Okay, for every employee object. So employee E1 is equal to downcasting employee object 1 to employee type. Okay, because we want a current object also, past object also. Here how you'll get current object and past object? Like this, you have to downcast to two employees. So employee E2 is equal to employee of O2. Now we have to write a logic for it. See, it is same. Okay, it's same like a compare to, but here it is little different. Here we are downcasting to two employee objects at a time. Okay, so object O1 and object O2. So this object O1 is downcasted to type employee 1 and object O2 is downcasted to type employee 2. Okay, employee 2. Now what we shall do is we shall go for the logic if current object E1 dot, suppose if we want to go for okay, so it is string, right? Ename is string. So what we'll do is we'll go for return E1 dot ename dot, we shall use compare to method, compare to of E2 dot ename. Since we are comparing a string, okay, since we are comparing a string, you can go for compare to also. You can go for compare to also. Okay, next. Here we are done with overriding compare method for sort by ename. See here, this is we are downcasting two objects of compare to a employee type. We are downcasting to E1 and E2, and We are returning by comparing the data. So after, if the employee names are same, obviously it will be sorted. Okay. And here all the employee names will be sorted, and the logic by default in compare to method it will be present. Okay, so by default in compare to method it will be present. This is for sort by ename. Okay, next we shall go for second one. Ename is done. Now let us go for employee ID. Class sort by employee ID. Sort by employee ID. So what we have to go for is implements comparator interface. Okay, after that we have to override compare method. Okay, so let us take all this. Same thing will be the same thing, we have to downcast. Okay, now so since the the employee ID is an integer. Okay, so we cannot go for compare to, we shall go for writing the logic. If even dot employee ID equal to dot employee, then zero. Else if even dot employee ID is greater than e2 dot employee ID, shall go for returning -1. Okay, then else, oh sorry, we have to return +1. Okay, else if employee even dot employee ID is less than e2 dot employee ID, we shall go for returning -1. Okay, so this is how we will go for employee ID. Sort by integer elements. No, integer you can go for logic. Integer elements can go for directly logic, but string elements go for compare to method. String attributes go for compare to method. Okay, you can't compare like this. You can't use like this for a string. Okay, you have to only use compare to method. Okay, this is how we will sort by employee ID. Sort by employee ID. That is done. Let us create a class for sorting the last attribute, that is salary. By salary implements comparator interface. Implements comparator interface. Next. Now what we shall do is same if the same logic, if even dot salary is equal to e2 dot salary. If both are same, we shall returning 0. Else if even dot salary is greater than e2 dot salary, we shall return 1. Else we shall return -1. Okay, same logic. Okay, no difference. See here, integer elements you can apply this logic by using compare method. Okay, but string you have to go for compare to, because inbuilt there is a logic for that. Okay, so that's it guys. See, what we are doing here is very simple. We have to, voice is breaking. Guys, all of you, is my voice breaking? Okay, can is it okay now? Is it fine now? Is it fine now, everyone? Okay, when it was breaking, how many times it was? Ename method explanation. Okay, ename. See, okay, I'll explain you again. See, if you want to compare ename, okay, this downcasting we have to already do because we are converting these two objects as a employee type because we have to compare current object with a past object. We have to compare. They should be of comparable type. They should be of comparable type. If it is not of comparable type, we will get a class cast exception. So that is why first we have to downcast them to employee type, and we have to use a compare to method to compare the enams. If we try to use this logic, we will not be able to do it because it is not integer, it's a string. It's a string. Since we'll be using string, okay, obviously we have to go for a compare to. Next, so sort by employee id. Sort by employee id. So when you're sorting, same thing, override compare method from the comparator interface. Then we have to write this logic, same logic. If e1 dot employee id is equal to e2 dot employee id, then we have to return 0. If e1 dot employee id is greater than e2 dot employee id, we have to return 1. Okay, and if else, else, if e1 dot employee id is less than e2 dot employee id, then we have to return -1. Okay, same logic here also for the salary. Okay, now after this, see, we are doing in ascending order. Okay, we can convert all these to descending order also. Okay, so name we can't do, but employee id and salary we can take in a descending order. Now which one we will do? We will Okay, so I think you guys got it now. Okay, so here for employee id or for salary, for which one we will go for descending order? Which one will go for employee id or salary? Anyone will go. Both if you go also no problem. Anyone we will go for the reverse logic. That's a descending order. Which one will go for employee id or salary? Salary, yeah, okay. So sort by salary we have no. Let us copy the whole class here. I will tell you how to do it. Okay, sort by salary in descending order. Okay, sort by salary in descending order. Now what you have to do, you have to change the logic. Let equals to is there, no, let it be like that only. Okay, let it be like that only. Now what you have to do is, if e1 dot salary is greater than e2 dot salary, you return minus value, or else you return plus value. That's it. That's all change you have to make. For descending, now if it is equal to current salary and past salary is equal to, then obviously you can return 0. But if a current salary is greater than past salary, you have to return -1 because we have to go for descending order. You have to go for descending order. That is why. Okay, now if it is not greater, if it is lesser, if a current salary is lesser than a past salary, then obviously we'll go for 1 because we have to go for a descending order. Not only 1, you can write any positive value. You can write any positive value. Literally any positive value you can write, and any negative value you can write. But if it is equal to no, okay, e1 dot salary equal to e2 dot salary, you have to return 0 only. Okay, so now that's all about your comparator interface. Now actual thing is we have to create one driver class. So we shall create an employee driver now. Employee driver class. Now in this employee driver class, we'll go for main method. Okay, now after this here, now what we'll be doing is, okay, what we'll be doing is we shall go for creating 5 employee objects. We shall go for creating 5 employee objects. Employee e array is equal to new employee of no argument constructor. We have to create an array of 5 objects. Now, starting from employee 0, okay, employee of 0 is equal to new employee of. All the data we have to give. Okay. So for a convenience here, now I will take your names. Okay. I will take your names. Some other data might come. Okay. If I am giving less salary, less salary if I am giving for you here, please don't mind. Okay. Samiksha will take. Samiksha. And here, okay, we'll take employee over employee ID and salary. Okay. So ID we shall go for 4. Salary, how much salary you want, Samiksha? Samiksha, how much salary you're expecting in the program? Excuse me. 30K, okay. Okay, so we have 30K here. So we have 30K here and your employee ID is 4. Employee name is Samiksha. Okay, next. New employee of. Okay, next. We'll go for Sankit. Sankit and employee ID is, we'll go for 2. And here, what salary you're expecting, Sankit? Oh, 45K. Okay. Next. Employer 3. New employee of. Okay, we'll go for Pooja. Okay, I'm just taking your names from top to bottom order. Okay, whoever names is coming, I'm taking. So employee ID, can you 3 or we'll go for 5? Yes, 50K. Okay. Okay, next. Employee 2. New. Yeah, I'm giving you all in increasing order only it is there. Okay, I will shuffle later. Okay. Okay, next. Samiksha, I think I've taken. Next, Preeti. Employee ID 1 and salary, Preeti. Preeti, what salary you can expect? Preeti, what salary you can expect? Or I'll give one salary now. 60,000. Okay. The array of 2, your array of 3 should come. Okay. Next, employee. Fourth employee 0, 1, 2, 3, 4. So last employee, new employee. Yeah. I have changed it now. Okay, Tejashwini. Let's take next one. Okay, ID will go for 3. Tejashwini, what salary I can give you here? 40,000. Okay. What I'm gonna do is I'm gonna reduce the values here. Okay, I am reducing values for time purpose. Okay, you cannot have all these salaries in the same order. Let us have it in a shuffled way. So you'll get to know if it is shuffled also, you'll get in a sorted manner. Okay. So, okay. Okay, we'll go for 65,000, 15,000, 45,000. Okay. And 23, 45, 15,000, 65, 40,000. Okay, now it is not in one order. It is not in ascending order also. It is not in descending order also. And don't mind if I'm interchanging salary here. Okay, this is not exact salary. You have a capacity of earning more than this. Okay, So what is the next thing is we have created an employee object. Okay. How many other objects we want you can create, but I've taken only 5. Next, what is the next step? So what did we do in previous program? After this step, what did we do in previous program? In the book? Whom we called in the previous program? Yes, guys, tell me whom we called in the previous program after creating the object, array object, arrays.sort method. Here we have got arrays.sort method. But here there's a slight change. It's not sort, it is sort. Array.sort method, SORT. Okay, now what we shall do is we have to call arrays class arrays dot from util package arrays dot sort method of. Now what we have to do is we have to pass the array object, array employee object, comma, in the next argument we have to create an instance. Now for which one we'll go for? We have to create an instance. Okay, first one we'll go for sort by ename. Okay, so first we have to create an instance, that is new sort by ename constructor. So now your sort by ename. So all the names has been sorted now. All the names has been already sorted. How? Because first you have to pass an array. Then you have to create an instance. Okay, you have to pass an array. Okay, employee array e. Now next you have to create an instance. Why we have to create an instance is we don't know whether if we want to compare for employee name. Okay, whether we want to compare for employee name or employee id or employee salary or in descending order to whichever class we want to sort. Okay, that class instance you have to create here. So what we have to do to sort these employee objects, what you have to do, you have to pass the array reference first. And then here which class we want to sort, whether sort by ename or sort by id, whichever, that class instance you have to create here. Okay, that class instance you have to create here. Now we'll go for loop because already employee names are sorted. Okay, so to know that we have to go for loop. For int I is equal to, starting from index 0, I less than e dot length and I plus plus. Now what we shall do is, we'll go for, okay, array e of I dot ename. Okay, now if you execute, you'll get all the names in an ascending order. Now can you guys tell the names in ascending order accordingly to the alphabets from A to Z? Okay, from A to Z, which one will come first? Which name will come first if you are going accordingly into the alphabets? Yes, which one will come? If you are sorting it accordingly to the alphabets, which one will come first? A to Z. Okay, so I'll just mention 1. Puja 1. Okay, next. Okay. Preeti Puja. POPQR. Puja will get first, Preeti will get second. Next. Samiksha will get third. Ankit will get fourth. And will get 5. Okay, let us see the output. Okay, let us elaborate. Okay, what are we getting? First is Pooja, second is Preeti, third is Samiksha, fourth is Sanket, fifth is Tejaswini. Now, how did I write it? Okay, how did I write it? Without seeing the output, how did I get to know only these names will come? See, first one is Pooja. However, I've written it is the second one is Preeti. Third one is Samiksha. Fourth one is Sanket and fifth one is Tejaswini. How? Because you have to take an alphabets. If the first letter is same, You have to start, if second letter is also same, you have to start from the third one. M, after M only N will come. After M only N will come. So third one is Samiksha and fourth one is Sankhya. So when P and P are there, okay, Pooja and Preeti are there. MNOPQR. Okay, so first Pooja will come, then Preeti will come. So after all this, T will come at the last. Okay, so that is why I have taken 5 for the Tejaswini. So this is how you can sort the names in an ascending order. You can sort the names in ascending order. Okay, next. This is for the sort by e-name. Okay, this is for sort by e-name. Next, we shall go for sorting the next attribute. So what we have to go? What will we do? We have to sort means you have to call the sort method. You have to pass the array E. Okay, we have to pass the array E. And now here we have to pass the instance of the object. Okay, I mean whatever the class. Now e name is done. Now let us go for employee ID. Okay, so now if we sort, you'll get all the employee IDs in a ascending order. Now can you tell me the employee's ID in ascending order? Can we create a duplicate here? Duplicate. Okay, where which data you want to do duplicate? Which data you want to make a duplicate? Name. Okay. Then we have to repeat any one we have to repeat. Okay, what will do? Sorry, I saw the salary. Okay, it's okay. No problem, guys. Any e-name, e-id. If you mix and recreate an instance also, no problem. Same thing will be there. Okay. So what we'll do is, we will repeat the name Pooja. Okay, we'll repeat the name Pooja, and obviously you'll get the name Pooja and Pooja. Okay. See, Pooja and Pooja, you'll be getting side by side. So copied names or repeated names, along with that only, you'll get it. Got it, Saurabh? Saurabh, got it? Okay, so salary also no problem. Now, can you tell me employee's ID accordingly to the increasing order in an ascending order? Employee IDs? Employee ID is not names. Employee IDs. Employee IDs are 4, 2, 5, 1, 3. If you take in an ascending order, it will be 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. So if you execute, you'll be getting employee's ID in ascending order. Okay, I have not given here, right? EID. Okay, if you execute, you'll be getting employee's ID. Can you see here? All the employee's IDs are been sorted. 1, 2, 3, 4, and 5. 1, 2, 3, 4, and 5. Okay. Now, we have sorted employee ID also. Okay. We have sorted employee ID also. So after this, we shall go for one line here. And so we will have some differentiation. Next. So sort by employee ID done. So after employee ID, we'll go for sort by salary. Okay, we'll create an instance for sort by salary. Okay, sort by salary. So E of I dot salary we will take. E of I dot salary. What did we do here? We have sorted, we have created an instance for sort by salary, and we are calling E of I dot salary. Now guys, you tell me accordingly to the salary in an ascending order. Now break down all the salaries now. Okay, first 15,000, next 23, next 40, next 45, next 65. We have mixed it, but we will still get it in a sorted way. Let us execute. Can you see it? 15, 23, 40, 45, 65. Okay. So all your salaries have been sorted. All your salaries have been sorted. Okay. Next. After this, last one is there. Okay. Last one is there. That is sort salary by, okay, I mean sort the salary in descending order. It's okay. No problem. Okay. Now what will go for? Sort by salary in descending order. Okay. Same thing. Same thing. Go for descending order. Let me see how many of you can do. Salaries in descending order. Go for salaries in descending order. You have told in increasing order, fine. But go in descending order. Let me see. Descending order. Can we sort like ID, name, salary in one line? No, we can't do that. See, if you want to do it, yeah, here we can do like separate classes we have to create. Okay, we can't do all things in one line here. Okay, we can bring it down to one line, but here we have to create a separate class for it and we have to sort it. We have to write a logic for sorting. In one line we can't, because see, every data is different. If you want to get in one line, one chance is every data should be in increasing order. Okay, every data should be in increasing order, but here in real life you'll never get it. All data will not be in increasing order. Okay, so ID will change, name will change, salaries will change. So in one line you can't get it. Okay, the thing is, so I mean like this. Okay, you're asking like this, right? In one line means you're asking like this. Can't we print like this? You're asking. No, we can't do that here because we are taking different objects. So here, once we have sorted, we are calling employee name, employee ID, and salary. Okay. Okay. Let us try to do it. Okay. So what we'll do is, we shall go for. Okay. So employee name, employee ID. Next, we'll go for salary. Okay. We shall try it here now. Okay. So employee name. Okay. Name. We shall go for E of I dot. Employee ID, and we shall go for E of I dot salary. Okay, so let us remove all of these things. Okay, so as you asked, we have brought down all these things to one line. Let's execute. Can you see here? What is the problem if we do it? Yes, what is the problem we are facing if we try to do in a same line? Yes, Saurabh, can you see the code and tell me what is the problem we'll face? Yes, the problem we face here is, however the data is, we are getting it as it is. Okay, not in ascending order. Yeah, not in ascending order. See, however data is, I mean, little has been changed. Okay, so based on the IDs and all, it has been mixed. Okay, it has been little, it has been mixed, but it is not in ascending. It is not even in descending. But lastly, we have sorted salary by descending order. So what did we get? We have sorted it normally in descending order. So we can't do it here. We shall get it back. Okay. So here we'll go for salary. Now, let us see the code. Okay, all the code you'll get it in normal ascending order. Okay. So guys, see the code here. First, names are being sorted in ascending order. Then employee IDs have been sorted in ascending order. Next, salaries have been sorted in ascending order. And we have sorted the salary in descending order also. We have sorted the salary. We have sorted the salary in descending order also. Okay. So this is how we'll sort the salaries. This will sort the salaries. Okay, and this is how we'll perform sorting without any sorting techniques, just by using sort method from arrays class. Okay, just by using sort method from arrays class, we can do wonders here actually. Okay, so I hope everybody understood. Everybody got the concept? Everybody understood? The thing is, you have to just see once what you have to do. Okay, you have to just practice once. Can you explain again in short? Okay, sure. See here, which one you want me to explain? Okay, which one? Comparable or comparator? Or both? Which one? Both are okay. See guys, here in the comparable interface, see comparable interface has only one abstract method, that is the compare method. Okay, compare to method. So this compare to method, okay, it's just acts like a equals method. Okay, it will just act like a equals method. But why we are writing this compare method is, you want to call arrays.sort method and you have to pass the variable of an array into this. So for this sort method, for this static sort method, it don't know in which order it should sort. It will sort, but in which order it should sort. The logic for that sort method is given in the compare to method. Logic for the sort method is given in the compare to method. Okay, so based on this logic, it will sort all the attributes. Okay, so here the drawback is any one attribute only we can sort. Okay, the drawback is any one attribute we can sort. And if objects is not of comparable type, obviously we will not be able to compare, and all the elements should be of same type, like homogeneous elements you need to have. Okay, if it is a book id, okay, all book IDs it should be of int type. If it is title, all title should be of string type. If it is a price, all the price should be of double type. Okay, next, here that first drawback is we can only sort any one attribute. Second thing is, okay, if any object is not of comparable type, we'll get a class cast exception. And here excuse me. And one drawback is, one more is, we can sort only in one order, that is in a natural order. We can sort only in one natural order. Okay, in only one natural order we can sort. Okay, in descending order we can't do it. Okay, in descending order, for that we can't do it here. We can change the logic and write, but by default it is only in one natural order. Okay, so that is in ascending order. So these are the drawbacks. You will get the output neatly. You'll get the output, but only one attribute you'll be able to compare. We have compared, I think, prices of the book we have compared. Okay, so we got it in ascending order. What you have done, arrays.sort, we have to pass the instance variable. Okay, and we have to go for a for loop to print. Okay, for us to see it. Okay, here already it got sorted. The second we used array.sort of b, it got sorted, but we are using this for loop just for our reference to see the output. These are the things. These are the three drawbacks which you'll find in the comparable interface. To overcome that, we have gone for comparator interface. In comparator interface, we can sort all the attributes. Okay, we can sort all the attributes, even if the objects are even if the objects are not of comparable type. They are not of comparable type. They are different objects. Even if they are not of comparable type, we can easily sort it. Okay, and Element should be of comparable type. Okay, whatever the data will have, no, data should be of comparable type. And here we can sort both in ascending order also and descending order also. We can sort in ascending order also and descending order also, just by changing the logic. Just by changing the logic, we can sort in ascending order also as well as a descending order also. Okay, so like this, the one change from that to this is we have to create a class for every attribute. For every attribute, if you want to sort every attribute, you have to create a class for that. You have to implement a comparator interface, then you have to override compare method. After that you have to create a driver class. Okay, and you have to create an array object. How many ever you want, you can create. Okay, how many ever you want, you can create, but make sure you mention the size here. Size of the array object you will mention it. Okay, after that, here we have called the sort method for all the classes. Sort by ename, sort by employee ID, sort by salary in descending order. Okay, so and then we got the output for all. Okay, we have got the output for all the attributes. Okay, so now all the attributes are in ascending and only last one is in descending because we wanted it to be in descending. That is why. Okay, so this is about a comparable and a comparator interface. Okay. Excuse me. I hope you guys got it. Everybody understood? Guys, did you get it? Let me know. Okay, guys. Okay. Okay, so here we ends here oops. Okay, actually oops has ended in abstraction only, but oops has ended now because we have completed interface. We had a problem in abstraction where we couldn't have 100% abstraction because of a concrete method, and that we have overcome in interface. And here we have the two important interfaces, that is the functional interfaces, comparable and a comparator interface. With them easily you can sort the objects. You can easily sort array objects. Okay, then after that after that now we shall see in the next class we'll have a revision. Okay, we'll have a revision in next class, but for today's class let us have one concept. It's a very common concept, okay, which you already are working on. You already know what it is. Okay, but let us understand why we use it. You already know it is an eclipse. Okay, but let us understand how to do it. Part 2 is not ended. Part 2 is still there. After completing string, part 2 will end. After completing string, okay. Currently, packages concept, access modifiers concept, string concept is pending. Did I send the portions to you? I think I've sent. Did I send portions to you? Okay. Yeah, it is there. No, after string completes. Yeah, part 2 is huge. Yes, part 2 is huge. So after we complete strings, part 2 will end. In a part 3, we'll start with exception, wrapper class. Okay, after that collection framework. Okay, then comes your this one, file handling, multi-threading. If time permits, extra concept, that is your lambda expression will do, because your advanced trainers, they will already tell you, they will explain you Java 8 features. Your advanced trainer will explain you actually. Okay, so yeah, you will actually study there until we complete multi-threading. Okay, we will have a classes. So when was your class started? Just a minute, let me check when it was started. Okay, once again. Okay, I am not able to see it. Okay, on 8th of last month. Okay, and this month is a 10th month. Okay, so 8th month done. 4th of 4th of August to next 4th of September is 1 month, and 4th of September to 4th of this October is 1 month. So 2 months will be completed after 2 days. Okay, so usually we complete the class within 2 months, but since the doubt session and the clarifying session, backup session has been more actually, so much doubt clarifications and all was there, so we were not able to complete, but it's okay. Within 1.5 week, within 1-2 weeks we'll be completing your portions. Maximum 2 weeks we can take, that's it. So the humble request from my side, it is for yourself, not for me. Study well. Okay, very soon, maybe this Sunday, you will have a part 2 assessment. Okay, part 2 assessment, mock, everything will be given. And guys, see, if you have paid so much amount to attend the class, you have to also attend the test. You have to attend the mock, you have to attend the oral mock, MCQ test, designability test. And this time I'm gonna give you one designability for sure. For part 2 itself, I'm gonna give you one designability. Okay, make sure go through everything. Okay. Okay, so let us complete your concept of packages and access modifiers today. It's a very revision we'll see in next class after OOPS has completed today. Okay, go through the concept. Still 2 more concepts is pending, not in OOPS. Designability means UML designs. Okay, we have studied UML designs. You guys remember? Unified Modeling Language Designs. We have broke down the class into a square boxes and we have mentioned attributes, methods and everything. You guys remember? You guys remember the designs we have done? Same thing. So try to go through the designs. There is so much things you have to study. I don't know what you guys are doing. Okay, if you're studying, that's a good thing. If you're not studying, start studying. That's it. Okay, so now let us get into our next concept. Just a minute, I'm getting a call. Excuse me, guys. Yeah, excuse me. I just got a call. Okay. So see, guys, 20 people are here. Okay, I don't know how many of you joined back. Okay, 20 are here. I want all 20 or 19 of you. Okay, two names are there. Let me count 1, 2, 3, 4, 5, 6, 7, 8, 11, 12, 13, 14, 15, 16, 17, 18, 19. Yeah, 19. Okay, 19 of you also should attend part 2 assessment. Will you guys attend part 2 assessment after strings? Very soon, the next day after strings, I will give you assessment. That is this Sunday. Everybody will attend. One of them also should not miss. Okay, it's not for me. Okay, it is for you. You want good mock ratings? No, you have to attend this. Because, yeah, topics part 2. Complete part 2 concepts. I've given portions. No, I've sent in group. Okay, see that portions. Part 2, complete part 2. Yeah, part 2 has taken some time, but it's okay. Okay, we have to learn everything in core. So it will take some time. Okay, minimum 2 weeks it will take to complete. Yeah, whole OOPS concept, everything from part 2. In part 2, everything will complete. Remaining is you have to just study about packages and access modifiers that we'll do today. From next class, Okay, first we'll have a revision next class. Okay, and after that we shall start with the string concept. Okay, we shall start with the string concept. Okay, so and tomorrow you might not have my class. That means I might not take a class for you, or we shall have a design ability test. So guys, tomorrow I am planning to give design ability test as I'll not be able to take class tomorrow. Okay, tomorrow I might not take class, or another trainer also might take your class, because I will not be able to take your class tomorrow. So make sure, be ready for the design ability test. Okay, be ready for the design ability test. See, for design ability test, no revision needed. For OOPS concept, revision is needed. But design ability test, everything will be there in design itself. You have to just break down into a code. Okay, so I might give this design ability tomorrow. Revision will do. But tomorrow, if I'm not taking class, I mean, obviously I'll not be able to take class tomorrow. So I might give you a test. Okay, the design ability test I might give you. So be ready. Okay, guys, so let us go on to our next concept, that is packages. Okay, let us see what are packages. Okay, so let us see what are packages now. One second, I'm just trying here. One second, let me see which is good. Okay. Okay, this is not nice. Okay, I shall go for this. Okay, this is nice. Okay, guys, so we shall start with your packages. Okay, I just want to ask you one question. Now, why we have to go for a package? You guys tell me, why can't we include all the concepts in one? Okay, under one. See, this is your project, right? So why do we have so many packages? Yes, any one of you? Why do you have so many packages? We have default, abstraction, array program, basics of Java, encapsulation, interface, object class program, OOPS, polymorphism, relationship. Why do we need to create a different packages? Why can't we include everything in one? Is any idea you have? Any idea? Any idea you guys have? You can unmute and tell also to clearly understand all the different concepts neatly. Okay, and to figure out different to what is this? To buy forget. No, guys, here. Okay, tell me, in one package, shall I have a same class twice? One class name twice can I create? Can I create in one package, under one package, one class name I can create twice? Is it possible? No. You got one reason? One reason is to avoid naming conflict. Okay, we have to go for packages to avoid the naming conflict. You don't have to worry, because under abstraction I might have one ATM class. Under array, under encapsulation I might have an ATM class. So that ATM and this ATM is different, and we can also avoid the naming conflict. Here ATM something something I have given, here something something I can given. So we have to just see the path. We don't have to worry about the names. Okay, and see, let me tell you the first reason. Okay, see, packages means what? First of all, packages in Java. Okay, packages in Java usually are used to group related classes and interface. Related to group related classes and classes and interfaces. Okay, and in a simple word, if you want to tell packages, you can tell it as a folder. Okay, or you can call it as a directory. Okay, which consists of many classes and interfaces. Classes and interfaces. Okay, next you have to know that packages under SRC only contain .java files. Okay, packages under SRC, whatever packages we have, if you have observed, we have only .java files. Yes, we have only .java files. All of them are .java files under SRC. Okay, so packages contains only .java files, that is class files. Okay, now packages means what? It's just a group of related classes and interfaces. We can also call it as a folder or a directory. Okay, then packages only contain Java classes, .java classes. Okay, now we will know why we need packages. The first reason why we need packages is packages are used to avoid name conflict or naming conflict. Okay, first reason, packages are used to avoid naming conflict. See here we have different names under every package. So many different names also will be there. Okay, so if I try to create one name, one more name with the same class name, it is not possible. There will be a conflict. It will tell, should we replace the old file with this new file? If you are doing on edit plus, it will ask, or notepad, it will ask. But here you can't do it. You can't create a same class name, like one more file with the same class name. So here you can, by default, now what happens, suppose if I create one under abstraction, now I will create one class. Okay, I will create one class here under abstraction, that is ATM. So what do we have here? What is it showing? Type already exists. Type already exists. We can create, but the type already exists. That time there will be some conflict. We don't want to do that. So to avoid naming conflict, we have to go for packages. So I can create ATM in abstraction also. I can create ATM in a interface also, in encapsulation also, in anywhere I want I can create. So first reason is to avoid naming conflict. Second reason is it will increase the maintainability. So increases maintainability. Increases maintainability, obviously. So how you can tell that it increases the maintainability? Because if you want to okay, so if you want to access a concept, okay, a code in one concept, suppose under OOPS, if you are going, you want to access a class account. Okay, where is the class account? In OOPS. Okay, where is the class account? In OOPS. So easily you can trace it. Okay, you can maintain the packages. If you want to go under encapsulation, so there is a sim class. Okay, you can easily find sim under encapsulation. Okay, and here easily whenever we want to go for ATM, where is ATM? Under abstraction. So like this you can access, okay, a different classes under different packages, and you can easily find out. See, if it is written properly in a proper sequence, obviously the maintainability increases. You have maintained that in a proper manner, so to access them also it will be very easy. So this is how you can increase the maintainability. So if you are, say suppose I want to know some concept under encapsulation, what I will do, I have to know what all the programs I have done under encapsulation. I can go to encapsulation and I check. So if I didn't maintain this package, if I didn't maintain the maintainability of these packages, obviously I'll not be able to find which is the program which I've done under encapsulation. Obviously I'll not be able to find which is the code and which is the program which I've done under encapsulation. I'll not be able to find. Okay, so this is about the maintainability. Second reason. Third reason why we need package is, okay, to categorize classes and interfaces. To categorize classes and interfaces. What do you mean to categorize classes and interfaces? See, Simple, different concept, different program. Their package created. Okay. See, here, here. Excuse me. See, guys, these are inbuilt member. I mean, these are a user defined member. So these are all user defined. All are user defined. So see, in interface, I am writing only interfaces. See, in interface, I'm writing only interfaces. In abstraction, I'm writing only the classes. If you are observing, in abstraction, I've written only classes. But in interface programs, I've written only interfaces. Okay, most of them are interfaces only. Now, if I want to differentiate the classes in one package and interfaces in one package, I can go for packages. Okay, to create different packages, I can go for. So here, your packages are also used to categorize or differentiate your classes and interfaces. Okay. The fourth reason is it increases access protection. Increases access protection. Okay. Now, so when I tell access protection, suppose assume you are writing a code. Assume you are writing a code, and suppose without finishing your laptop, what happened? Different concept, different program was there. Package create different between. Okay, see guys. See, suppose okay, assume you are working in a you are working under one project, okay, and you are working in a separate unit. Assume you have some enemies in your company, okay, like your colleagues. Your colleagues don't like you. Assume now you have kept your laptop open, but you have closed the project. Okay, you have closed the project, but you kept your laptop. And since they are also working on the same project, they knows which project on they're working on. Okay, now, and the thing is, they are working on a different unit. You are working on a different unit. So what happens is, if they want to access your laptop, okay, they know password also fine. Now, if they're trying to access, suppose you have a project E23. Now, in which project, I mean, in which package, okay, in which package and which code I was working on, in which package and which code I was working on, it will be difficult to find out. Okay, see, you can actually go for recent files. You can go for recent files. Yeah, they can go for recent file, but we really don't know which one. I mean, from top to bottom here, we can go for. You'll get to know. Suppose I'm clearing history. Okay, recent file, I'm clearing the history. Done. See, now I don't get any. Now, if I want to know which projects, if a person, okay, if an enemy, if they want to know which project you're working on, I mean, in which package you're working on, will they be able to know after closing all this? Suppose you have closed Eclipse itself, you have closed everything. Now, is it possible from this package? See, so many are there. If one was there, we would be able to know. But since so many here, only few are there. But in real time project, there will be so many. Like minimum more than 30 20 will be there. Okay, so is it possible to trace out which under which class I was working on? Is it possible? Is it even possible to go to check which class I was working on and what concept I was working on? Obviously it will not be able to, right? So here these packages are protecting, okay, the access. Okay, so here these packages increases the access protection. These packages will increase the access protection. Okay, and one more thing why we have to go for is to achieve code reusability. If a role is clear, then might he or she find role is clear. Okay, if they find also, okay, suppose assume okay, see, suppose assume we are under one project. Okay, we are all engineers and we are under one project. So there are so many units. Okay, there are so many units, and under so many units, so many people, I mean, different project managers and unit leaders will be there. Okay, under them you are just working. Okay, now a different units person can't come and access, but in case if it happens, they'll not know on which one you're working. They'll not know on which one you're working. Surely they'll not know. Okay, now guys, tell me. Yes, that is what I was about to tell. So if you want to access PAN card, so without a password, can you enter into a PDF of a PAN? Can you access the PAN in the PDF format without a password? Is it even possible? No. So it is also like a package, right? It is also like a package. The PAN itself is one normal folder. Inside that you will get all your details. You have a PDF format of it. So in that way also you can protect. Okay, so you can actually get a password for every unit, which is very secretized between them. So for this we'll have one, we can have one here, and we can have one. So in a folder level only and in a package level only we can have a passwords. So obviously the access will be limited. So like this also you can go for access protection. Okay, so that was about your increased access protection. And the fifth one is the last one. Fifth one is to achieve code reusability. Okay, code reusability. Guys, where do we get a scanner class? Where do we get a scanner class? From which package do we get? Yes, guys, java.util. Okay, fine. Dynamic is a package, huh? Hmm? Dynamic read is a concept wherein we will read input from users during runtime. That is called as dynamic read. Okay. So java.util is Shoshan. Now we will get this scanner class from java.util package. Java.util package. Now we don't remember how many times we have used this. Really, we don't remember how many times we have used this, because we have reused this n number of times. We have reused it n number of times. We even don't know how many times we have used this. So here, this is also one package. Java.util.scanner or java.util also is one package. So here we can go for a package to achieve code reusability. To achieve code reusability, we can go for. Okay. So these are the 5 reasons why you have to go for package. To avoid naming conflict, to increase the maintainability, to categorize classes and interfaces, to increase the access protection, to achieve the code reusability. Okay. Now, in packages itself, we have two types. Okay. First one is built-in packages. Okay. First one is built-in packages. Second one, we can go for user-defined packages. User-defined packages. See, one thing you have to know, in user-defined packages, no, we'll have only .java class. In user-defined packages, we'll have .java class. Okay. So remember carefully, in user-defined classes, we have only .java files. Okay, now I'll show you the inbuilt class. Under JRE system library, we have so many packages. Can you see here? We have so many packages. So java.base, if we go for now, under base, okay, under base, see so many folders further. Under that also we have some more packages. Now I'll go for java.io. Now can you see we have only .class files. If you're seeing here, we have only .class files under inbuilt packages. In inbuilt package, we have only .class files because they are bytecodes. If you want to share a code for development of a testing, you have to share in the form of bytecode. Okay, at least for development, you have written some code, you have to send your part of code to the development team, your project manager. Obviously, you have to share the code in a dot class format only. Okay, so here we have a dot class format of all files. Package contains only class files. That is inbuilt packages. That is only inbuilt packages. All inbuilt packages contains dot class files, but all user defined packages contains dot java files. All user defined packages contain dot java files. Okay. Next, now let us know the differences between your built-in packages and user defined packages. So first let us enter into built-in packages. Built-in packages. Okay. Okay, so let us get into our built-in packages. So built-in packages means what? Built-in packages. See, it is already there. Built-in means it's already there in your JRE. Okay, I mean in your library, JRE system library, you already have this built-in packages. Suppose it's like java.lang, java.lang, okay, java.util, java.io, java.sql, java.swing, java.awt, etc. So many packages are there. So many built-in packages are there. Okay, all these are included in your JDK, Java Development Kit. Okay, now see, there are so many built-in packages. Okay, there are so many built-in packages. Suppose if you take a scanner class, okay, java.util.scanner class. Now java.util.scanner class we do have. Now here your Java is a package name, your util is a sub package name, and scanner is a class or interface name. Here currently it is a class name, but in this position we can write class or interface. Currently scanner is a class only. Okay, Java is a package, util is a sub package, and a scanner is a class. Okay, and a package inside one more package. A package inside one more package is called as sub package. Is called as sub package. Okay, this sub package is used to categorize folders further. Okay, further if you want to differentiate. Suppose Java is a main package. Under that we have util, we have IO, SQL, like that. So many sub packages will be there. Okay. Next, after this, okay. Now let us see how to use built-in packages. How to use built-in packages. Okay. Now, see guys, there are two ways. There are two ways to use built-in packages. There are two ways to use built-in packages. First way is by using fully qualified name. By using fully qualified name. First way is by using fully qualified name. Second way is by using import keyword. By using import keyword. Okay. See, both we have not seen. We have only seen all these days. We have only seen using import. We have not seen using a fully qualified name. Right? We have not seen using a fully qualified name. Now let us see how we can use with the help of fully qualified name. Suppose you have one class here. Okay, class Java program. Class Java program. Now, and you have a main method, assume public static, and don't forget main method. I know most of you don't remember it. Don't forget. In interview, they might ask you to write in notepad. That time you will blink your eyes. Okay, don't just be like this. Okay, now I want to take input from user, so I have to create an object for scanner class. Usually what we do, we'll import Scanner class will create an object for scanner class. But there is one more way of doing it. So what it is, okay, that is one more way is by using fully qualified name. Now how to use a fully qualified name? Very, very, very simple. You have to go for java dot util dot scanner sc is equal to new java dot util dot scanner of system.in. This is how we use a fully qualified name. Okay, java.util.scanner sc is equal to new java.util.scanner. Now guys, you tell me, is it easy all the time? Is it okay all the time to use this? Can we use this like normally? If you want to spell it, how do you spell java.util.scanner sc is equal to new java.util.scanner of system.in? What is this java.util? Yeah, it is time consuming. Obviously it is time consuming. So to avoid this, okay, we don't want to do this actually. We will usually go for a shortcut. So what we have come up with is what we have come up with is will not use the scanner object every time. We can't use java.util. So the drawback, what will happen if you use every time is, okay, here by using fully qualified name, every time when we want to access a class or an interface, we will we will reduce the readability. So readability will be low. Readability will become low. So you'll not be able to read properly. Okay, you'll not be able to spell properly every time. So readability will become low if you use a fully qualified name. So to avoid this or to overcome this, we are using import statements. We will be importing it. Okay, whatever the classes and interfaces we have to use, we'll be importing and then we'll be working on it. So we'll import it. Import java dot util dot scanner class, will import it, and then we'll create an object for it, that is scanner sc is equal to new scanner of system.in. Okay, now this is the easiest way by using import statement. All these days we have learned using import only. This was a change using a fully qualified name. Okay. Now by using import statement, instead of using a fully qualified name, okay, we can directly use the class name and we can create an object. Okay, and if you are writing import statement, packages and a class in a same file, okay, now how to use in a proper way, how to use your import statement properly is, you have to follow this rule. First, if you have a class here, remember, if you have a class with a class name, if you have a class here with a class name, now what you have to do is first first you have to go for a package, then a package name, first package, last class with a class name. Okay, next, between this package and the class you have to write the import statement. Suppose if you're importing scanner class, import java dot util dot scanner of system dot in, scanner of system dot in. Okay, so we have a class and a class name here. Now here we can write whatever we want with the inside main method. Okay, if you're using an import in a class, if you're using an import statement in a class, first you have to write a package and then class, then between that you have to write an import statement. And not only one, you can have infinity number of import statement within the package and class. You can have infinity number of import statements within the package and the class. Okay, so this is how, three also if you're writing, this is how it should be. Okay. Excuse me. So this is how you have to use a built-in packages. Okay. Next, we will step on to next one, that is your user-defined packages. Okay. We'll step on to the next one, that is your user-defined packages. And you have to know that for a class, how many how many modifiers or access modifiers you can prefix. For a class, you can prefix public. For a class, you can prefix abstract. For a class, you can prefix final. Other than these three, you can't prefix anything. For a class, other than these three things, you can't prefix anything. Okay. So for a class, either public access modifier, abstract modifier, or final modifier, any one of these three only will be given. Okay. And you already know java.lang package is the only package which will be imported into the class. Okay. Java.lang package is the only package which will be imported during the creation of class by the compiler. Okay. Now let us learn about your user defined packages. Now let us learn about user defined packages. User defined packages. Okay. Now in user defined packages, obviously we can create our own package in our Java. We can create own package in our Java. Okay. Now how do you create? You have to go for a package. How it will be visible? The syntax is package and a package name. Package and a package name, semicolon. This is how a package appears. Suppose if you want to create a sub package, how can you create? You need to have a package. Okay. First you have to go for package name. Okay. Dot represents there's a link between these two attributes. Okay. Package name dot sub package name semicolon. If you want to create a sub package, this is usually possible in a notepad and any other IDEs except Eclipse. In Eclipse you can't do it. See, if you're creating a package, obviously one package will be created and you can't create a sub package there. Can't create sub package. Okay. So package name dot sub package. If you are creating a package like folders like this, you can create. Okay. Next. Here. Now there is one rules. Okay. There's one rules which you have to know when you're creating a class. Okay. So that rule is, okay. That rule is, now let us understand. Always remember, package is the first statement which should be written in a file. In a Java program, package is a first statement should be visible. Okay. And every Java source code, that is every .java file should come under one package. Every .java file. Okay. Every .java file should come under one package. And in a package, we can have multiple classes and interfaces. We can have multiple classes and interfaces under one package. We can have multiple classes and interfaces. And now, see guys, the thing is, if you take one file, okay, you can create n number of classes. In one file only, you can create a number of classes. But what you save the name as? File name as, how do you save? .java. Okay, extension is .java. Suppose you have a class A, class B, class C, and class D. Class A, class B, class C, and class D. Suppose these four classes are there. Now you have to name this file. Now can you tell me what is the name you can give now? Sanket scanner S is capital. Here scanner S, system also is a class name, so S is capital, semicolon. You have to end with. Now, yes guys, tell me. You have four classes. in one file. Okay, just now we have done no like that. In one file you have 4 classes. .java extension is there. Which class name you will give? A or B or C or D? Which one you will give? Which one you will give, guys? Which one? Can you guess? Which one you might give? Okay, I think you guys are in confusion. Can't say. Yeah, obviously. So the thing is, if any class is prefixed with a public, minimum in one file, minimum one class should be prefixed with public. So now you can take it save as a.java. Okay, the rule is n number of files, dot java, classes you can have, n number of classes you can have in one file, but there should be at least one class prefixed with public. It should be at least it should be one class prefixed with the public, and that class name should be a file name also. The class which is prefixed with public and the file name also should be the same. Okay, this is the thing. Suppose if you want to create, if you want to prefix public for each class, no problem. You can do that also. You can do that also. How it is you can create a different files only. You can create different files only. A, B, C, D, E. Prefix public for all. No problem. Public A.java. Prefix public B.java. Prefix public C.java. Like we do know usually. So you can create any number of files with any number of names and with .java extension. Okay. And if you don't follow this rule, okay, that is, if you don't follow this rule that any one class at least should be prefixed with public, if you don't do that you'll get a compile time error. Okay, you'll get a compile time error. Okay, now, and remember one last thing for today. Okay, one last thing for today, remember it. What that is if you want to use package import and a class, okay, you have to use in this way. First package, next import. After this you can use a class, or you can go for an interface, or you can go for an enum. Any. First package, then import, then any class or interface or enum. Okay. So here we end our today's session. Okay. Here we end our today's session. This was just about the simple packages, built-in and user-defined. We have already used it. Okay. So yeah. Enum means, okay, you know the value of pi. What is the value of pi? Anyone? Value of pi? Yes. Value of pi is, it will be like this. Value of pi. Okay. Value of pi. It is 3.14. Value of pi is 3.14. Now, there are some things. Okay. Yes, 22/7. There are some things which are constant. Can you name any? Can you name anything which are constants? Okay. Now, value of pi is constant. Anything else is constant? Anything else? Okay. So the things which are constants, okay, the constant date or constant time, okay, the date, time, whatever, if it is a constant, then we will surely go for enum. You'll surely go for enum for writing constant. See, you guys remember? Speed of light. Yes, speed of light is also constant. Date of birth, date of birth, date of birth, speed of light, right? Speed of light is 8 minutes and some seconds, right? After 8 minutes only. Now, these are some constants. So to have these constants, we need one class kind of thing. So that kind of class is your enum. Here you'll not study that. You study in advanced class. In enum, you'll have only constants. Okay, in enum, you'll have only constants. Okay. Okay, guys. I hope everybody has understood today's concept. Everybody got the concept? Let me know. Okay, guys, then fine. Okay, notes will be sent to you. Okay. Can we modify the package? No. See, if you select the package, right click. Now, okay, see here, refresh, restore. There is no option here. You can't get it. Okay, see. See, under package, you can create a folder, but package inside package here you can't create. Okay, so it is not possible. It is not possible. You can't change the name of it. Okay, you can't change the name. Okay, so obviously you can't edit the package. So well, before creating packages, you have to be careful. Now we can't modify package. Okay, guys, that's it. That's it for today, and I'll see you guys in next class. Have a great evening, guys. Take care. Bye bye. Do study. Okay, do study and come. Have a great evening. Take care. Bye bye. Good night. If we delete package, then how to restore? Okay. Uh, okay. Okay. Is it okay if I tell you in the next class, Sanket? Okay, I'll tell you in the next class. Okay. Okay, guys. Bye bye. Good night.